Okay, welcome to my next video, dear students. In this video, we are going to discuss about the numerical problems from the topic electric fields, electric dipole and dipole moment. So before going to solve numerical problems, let us learn about the basic concept or the synopsis for electric field, electric dipole and dipole moment. So first of all, what is electric field? So if I consider a charge here, its influence will be spread all around it. So at this particular point, what is the magnitude of its influence? What if I place a test charge here, and what is the force experienced by it? Okay, so that is called electric field. So this space around any charge in which its influence can be experienced by other charge or charges is called electric field. Simple. So one more definition is there for that. What is that? The electric field or electric intensity or the electric field intensity, we can call in either way, at any point is defined as the force experienced by a unit positive charge placed at that point. So now here I have a unit positive charge, means its magnitude will be 1 coulomb. So what is the force experienced by that test charge, unit test charge? That is considered as electric field at this particular point. Okay, so mathematically we can write that like this. So E is equal to F divided by Q. So we know what is electric force, that we have already studied from the concept called Coulomb's law or Coulomb's force law between two charges. So here we have two charges, one is Q and the other one is Q naught. Then Coulomb's force formula is given by 1 by 4 pi epsilon naught Q naught divided by R square into Q naught, as it is here. Q naught will cancel out, so you'll be having Q naught will cancel out. You'll be having E is equal to 1 by 4 pi epsilon naught Q by R square, as it is, and R cap is the unit vector. Okay, so then this is all about electric field. Then we have electric dipole. What is a dipole? As the name indicates, it will be having two charges separated by some distance. So since it is electric dipole, we have to consider electric charges. So what is the definition for that? A pair of equal and opposite charges separated by a small distance is called an electric dipole. Two equal means q, okay, but opposite in what is this, polarity. Okay, so when they are separated by small distance, here we consider the distance as 2a, distance between the two charges. So diagrammatically we can write like this: plus q and minus q separated by 2a. Example for that is water, ammonia, HCl also we can consider, carbon monoxide. These are the examples for electric dipole. Okay, so here we will be having two ions, one is positive and the other one is negative, separated by small distance 2a. Okay, so then we have the last concept, that is the dipole moment, that we are going to deal in this video. Let me define it first. So the dipole moment of an electric dipole is a vector whose magnitude is equal to the product of magnitude of any either of charge or any one charge and the distance between them. So that means we have to consider one charge, either charge. It may be q or minus q, but magnitude if we take, it will become positive. Okay, q into distance between them, we know that is 2a. Okay, so mathematically that is written like this: p is equal to q into 2a. Then the direction is from negative charge to positive charge. So if I consider a positive charge here, negative charge here, they are equal in magnitude but opposite in polarity, and they are separated by small distance 2a. This is called a dipole, and dipole moment is represented by p. That will be from negative to positive. The direction is from negative to positive, so that we write like this. This is dipole moment and this is dipole, electric dipole. Along with this, we have two more concepts that you need to know. Okay, so electric field at an axial point of a dipole. We have studied about electric field, we have studied about dipole separately, but it is the mingle of both of them. So we have a dipole here, so this exerts some force if you place one charge here, and this charge also exerts some force on the charge if you place here. Okay, so together what will be the force acting at that charge? If we consider that unit positive charge, we can easily find out electric field also. So at this particular point, what is the electric field due to this dipole, and this charge is placed axially at a distance r from its center. Okay, so derivation for this I will explain in the future videos. Once I start teaching the theory concepts, so I will explain the derivation for this and how this one is derived. Okay, now as of now, do remember this: E is equal to 1 by 4 pi epsilon naught 2p divided by r cube. So this formula is suitable when we consider a value from here to here. We consider the distance as a. When a value is so less than r, then we consider this. Okay, so if it is not, then the formula will be this one. Do remember this one also: E is equal to 1 over 4 pi epsilon naught 2 pr divided by r square minus a square whole square into p cap. Okay, so this is the formula if we don't neglect small a. If we neglect small a, compare it to r square. Okay, so then we will get this. In the same manner, we have the electric field at a point on the equatorial plane of a dipole. So here we have the dipole, minus charge, plus charge, and the dipole moment is in this direction. At this particular point, what is the electric field? In this case, we have considered what is this, axially. In this, we are considering equatorially at a distance r from its center. So for this, electric field is given by E is equal to 1 by 4 pi epsilon naught p by r cube. R, if we don't neglect a value here, if a is comparatively valuable with r, then we write the electric field like this: E is equal to minus 1 by 4 pi epsilon naught p divided by x square plus a square, not x square, this is r square, right? Yeah, r square plus a square power 3 by 2 into p cap. We write minus sign here because electric field is opposite to dipole moment. Dipole moment is in this direction, electric field is in this direction. In the same manner, we can consider minus sign here also because p is opposite to e. So these two are the formulae that you need to remember. Derivation I will explain later. Okay, let us start with solving numerical problems on these theory concepts. So first of all, we have two charges plus 6 nanocoulomb and minus 6 nanocoulomb are placed at 0.2 meter apart. So from this only we can get to know this one is a dipole. Okay, so calculate electric dipole moment. We need to calculate electric dipole moment and electric field. Electric dipole moment is P is equal to Q into 2A, because electric dipole moment is the product of one of the charges and the smallest distance between them, that is 2A. Okay, so P is equal to Q into 2A is the dipole moment. Then we have to find out electric field due to the dipole at a point perpendicular to the axis at a distance 0.2 meter from the midpoint of electric dipole. So here we have two cases. One is finding electric dipole moment and finding electric field. That is second one, electric field due to the dipole at a point perpendicular to the axis at a distance 0.2 meter from the midpoint of electric dipole. So I will explain that later. First, let us solve electric dipole moment. Okay, now electric dipole moment, we know P is equal to Q into 2A. So Q is given, Q1 is given, Q2 is given, and R is given. They are separated by distance 0.2. So let us calculate dipole moment first. So dipole moment P is equal to Q into TA. Consider any one of the charges, magnitude of any one of the charges, that is 6 nanocoulomb into 2A is how much? 0.2 meter. Nano is how much? 6 into 10 to the power minus 9 coulomb into 0.2 meter. If we solve that, 6 2s are 12. That means 1.2 into 10 to the power minus 9 coulomb meter is the answer for this simple for explanation. Okay, so this is the dipole moment, but we need to find the electric field. Let's just do that. So according to this question, we have electric dipole here. One is plus 6 nanocoulomb and the other one is minus 6 nanocoulomb. They are separated by 0.2 meter, but we need to find out the electric field at a point perpendicular to the dipole at a distance 0.2. That means this will give R in meter. Okay, so electric field here is given by this formula that we have already studied. So this is the question. So E is equal to 1 by 4 epsilon naught P divided by x square plus a square. We know x, or we can consider it as R also. Okay, R square plus a square power 3 by 2. R is how much? 0.2. And A is how much? A is, see, the complete thing is 2A. A is 0.1. Here 0.1 meter. Okay, so if we substitute those values here, we will get 1 by 4 pi epsilon naught is 9 into 10 to the power 9 into P value is how much? P value is calculated 1.2 into 10 to the power minus 9 divided by R square plus A square. R square is 0.2 square plus A square is 0.1 square whole power 3 by 2. So that is equal to, if you solve, you will get somewhere around 10.8 divided by 0.111. And again, if we solve, you will get 9.729 into 10 to the power 2 Newton per Coulomb. This is the electric field at a point perpendicular to the electric dipole. Clear? Thank you. Yes. The second question, that is, find the point on the line joining the two charges 12 nanocoulomb and 3 nanocoulomb where the resultant field is 0. Electric field, resultant field is nothing but electric field is 0, and the distance between the charges is 1.2 meter. So we need to find this particular distance from 3 nanocoulomb or 12 nanocoulomb where the resultant electric field is 0. Since electric field due to 3 nanocoulomb is in this particular direction, since it is positive, the electric field due to 12 nanocoulomb will be in this particular direction. So this is the electric field due to this one. Let's consider this is the charge at B, this is the charge at A. So electric field due to B is in this direction, electric field due to A is in this direction. So here at this particular point, the electric field will be 0 because EA is equal to EB. Okay, so now what do you need to find? We need to find the point on the line joining the two charges. So distance between the two charges is given. How much is that? 1.2 meter. Complete distance from here to here is 1.2 meter, but in between the two charges there is a point where resultant electric field is 0 because EA is equal to EB. So now from this you need to find out the distance of this point from 12 nanocoulomb or 3 nanocoulomb. So I am considering this distance as x, so that the distance from A to this point P will be 1.2 minus x, right? So now EA will be in this particular direction, so that can be written as 1 divided by 4 pi epsilon naught q a divided by distance between these 2 points is 1.2 minus x whole square. So that is equal to 1 over 4 pi epsilon naught qb divided by uh, x square. Yes, distance between these two is x. So now 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will cancel out. QA is how much? 12 nanocoulomb. 12 nanocoulomb divided by 1.2 minus x whole square, that is equal to QB is how much? 3 nanocoulomb. 3 nanocoulomb divided by x square. So now here the units will cancel out. Nano will cancel with this nano, and coulomb cancel with this coulomb. Okay, then 3 4s are 12. So then we will be having 4 divided by 1.2 minus x whole square, that is equal to 1 divided by x square. We need to find x here. So let's take square root on both sides. Square root of 4 is 2 divided by 1.2 minus x is equal to, on right hand side we will be having square root of 1, that is 1 divided by square root of x square is x. Let's solve for this. X 2 is 2x, that is equal to 1.2 minus x. Now if you bring this x to left hand side, you will get 3x is equal to 1.2. Now what about x? X is equal to 1.2 divided by 3. So 3 4s are 12, so you will get 0.4 meter. Now this gives the distance of the charge from this point P. Which charge is that? The charge at B. So this distance is 0.4 meter. So what about this distance? The distance of this point from the charge QA is 1.2 minus 0.4, that is 0.8 meter. That's it. Thank you. Okay, we have the third question here, that is 2 point charges 4 microcoulomb and 2 microcoulomb are placed at the vertices A and B of right angle triangle ABC respectively. Okay, so B is the right angle, that means this angle is 90 degree B. Okay, so AB, that is the side, square root of 3 centimeter, AC 2 centimeter, BC 1 centimeter. So diagrammatically we can write that like this. Okay, so we have this triangle ABC. This side is given AB, how much is that? Root 3 centimeter. AC is given, how much is that? 2 centimeter. Okay, so then BC is given, that is 1 centimeter. Okay, so according to data we can write like this. Then what do we need to do here? Calculate the magnitude and direction of the resultant electric intensity, electric field strength, or electric intensity also we can call. Okay, so that is E, direction of E we need to find. Not only magnitude, we have to find out direction also. So let us find the magnitude first, then we can find out the direction. Here we have two charges. One is 4 microcoulomb and the other one is 2 microcoulomb. Okay, 4 microcoulomb, this one is positive. 2 microcoulomb, this one is also positive. Okay, now if this one is positive, the electric field due to this charge at this particular point will be in this particular direction. If it was negative, it would have in this particular direction, but it is positive, the direction of electric field will be in this direction. Then QA is also positive, the direction of electric field at this particular point will be in this particular direction. Okay. Now, the resultant electric field will be in this particular direction. So let me write that as E resultant. So if I want to find E resultant, I need to have EA as well as EB, because the formula for resultant electric field is EA square plus EB square plus 2EA into EB into cos theta under square root. And what is theta here? We don't know its value. Let us calculate that. See, from the data that they have given, I can easily calculate theta. Sin theta is equal to opposite by hypotenuse, that is root 3 by 2. So theta is equal to sin inverse root 3 divided by 2. So from that we will get 60 degree. Sin 60 degree is root 3 by 2. So that's why theta value is 60 degree. This will also be 60 degree. Now let us first calculate EA, then EB, then we can easily find out ER, because theta is already known. EA is equal to 1 by 4 pi epsilon naught QA by its distance. So EA is nothing but the electric field at this particular point. 1 by 4 pi epsilon naught QA is how much? 4 microcoulomb, and distance between them is 2 centimeter. 2 into 10 to the power minus 2 meter. So 1 over 4 pi epsilon naught QA is how much? 4 into 10 to the power minus 6 coulomb divided by 2 into 10 to the power minus 2 whole square. So if you solve that, 1 by 4 pi epsilon naught value is 9 into 10 to the power 9 into 4 into 10 to the power minus 6 divided by 2 to the 4 into 10 to the power minus 4, because 10 to the power minus 2 whole square 10 to the power minus 4. If you solve that, you will get A value as 9 into 10 to the power plus 7 Newton per coulomb. In the same manner, you can solve for EB also. 1 by 4 pi epsilon naught value is 9 into 10 to the power 9 into EB value is how much? 2 microcoulomb. 2 into 10 to the power minus 6 coulomb divided by distance is 1 into 10 to the power minus 2 whole square, that is nothing but 10 to the power minus 4. So from this we will get 9 to the 18 into 10 to the power 7 Newton per coulomb. So this is the value of EB and this one is the value of EA. Now we need to find out ER. Okay. Now the resultant electric field intensity at C is given by E is equal to square root of EA square plus EB square plus 2AA into EB into cos theta. Now what is EA? 9 into 10 to the power 7. Yes or no? Yes. Plus EB is how much? 18 into 10 to the power 7 whole square plus 2. EA is 9 into 10 to the power 7. EB is 18 into 10 to the power 7 into cos 60 degree, that is cos 60, that equals 1 by 2 under the square root. Solve this. If you solve this, then is a 81 into 10 to the power 14 plus 18 squares 324 into 10 to the power 14 plus cos 60 is nothing but 1 by 2. 1 by 2, 2 will cancel out. 9 into 18 is 162 into 10 to the power 7 into 10 to the power 7 is 10 to the power 14 under the square root. So now what I will do, I will take 10 to the power 14, 10 to the power 14, 10 to the power 14 as common. So then I can get 81 plus 324 plus 162 into 10 to the power 14 under square root. So 81 plus 324 plus 162 is nothing but 567 into 10 to the power 14. If we take square root for that, you will get 23.811 into 10 to the power 14 squares. I mean, under the square root, you will get 10 to the power 7 Newton per Coulomb is the unit. So this is the resultant electric field. Okay, so that is this resultant electric field. So we have found the value magnitude of that value, but we need to find out direction also. So what I will do, I will find the direction of electric field, resultant electric field with respect to EA. So I will take this as alpha. Okay, then if I found alpha, we can say ER is making an angle alpha with EA. Okay, so now we need to find out alpha here. So there is a formula for that, that is this: tan alpha is equal to EB sin theta divided by EA plus EB cos theta. So that is equal to tan alpha. EB is how much? 18 into 10 to the power 7 into sine 60 degree divided by EA is 9 into 10 to the power 7 plus EB is 18 into 10 to the power 7 into cos 60 degree. So if you solve this, you will get tan alpha is equal to 18 into sine 60 is 0.866 divided by 9 into 18 into cos 60 is 0.5. What happened to this 10 to the power 7? I have taken that as common in both numerator and denominator. So both will cancel out here. So then tan alpha is equal to, if you solve this, you will get 0.866. So then if you solve for alpha, it will give you tan inverse 0.866, that is equal to 40.9 degree. Okay, so this is along which direction? In this particular direction. So we can consider, so this direction as CP. So EB is along CP. You can consider this direction as CR and this direction as CQ. So now this ER is making an angle 40.9 degree with CQ. Okay, so this is along which one? CQ. That is all about this problem along CQ. So last question: 2-point charges QA is equal to 5 microcoulomb and minus 5 microcoulomb, that is QB, are located 0.2 meter apart in vacuum. Okay, so what is the electric field E that we need to find out at the midpoint P on the line AB joining the two charges? So if the negative test charge of magnitude 2 nanocoulomb is placed at this point, what is the force experienced by the test charge? Here we have two cases. One is we need to find out electric field at midpoint P. So we have two charges. Let's consider the case one. We have two charges. One is 5 microcoulomb and another one is minus 5 microcoulomb. So electric field at this particular point is how much? That we need to find out. See, electric field due to this one at this particular point will be towards negative. So like this is electric field due to EB, and in the same manner electric field due to this positive charge will be in this particular direction only, because the direction of electric field will be radially outwards and electric field due to negative charge will be radially towards it or inwards. Okay, so this is EB. So now, sorry, EA. So now the total electric field will be EA plus EB. Okay, let us calculate that. EA is how much? 1 by 4 pi epsilon naught QA divided by this distance is how much? See, total distance is 0.2. This distance will be 0.1 meter. So this distance is also 0.1 meter. So 0.1 whole square. Okay, plus EB is 1 over 4 pi epsilon naught QB divided by 0.1 whole square. So that is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught can be considered as 9 into 10 to the power 9. Common term QA is how much? It is given 5 microcoulomb. 5 microcoulomb divided by 0.1 whole square plus QB is how much? 5 microcoulomb again. Magnitude of that, because both are in the same direction. If they are in different direction opposite to each other, we have to consider minus sign here. Since they are in the same direction, we have to consider plus sign here. So divided by 0.1 whole square. Okay, so that is equal to 9 into 10 to the power 9. We have 2 times of this into 2 into 5 micrometers 10 to the power minus 6 divided by 0.1 whole square. Simple mathematics, because we have 2 times, that's why I have written 2 here into same thing I have written here. Okay, so that is equal to, if we solve this, you will get 9 2s are 18. Okay, then we can solve this. 5 2s are 10, 10 2s are 10 9s are 90 into 10 to the power 9 into 10 to the power minus 6 divided by 0.01. Okay, so that is nothing but 10 to the power minus 2. If you solve this, you will get 9 into 10 to the power 6. Okay, what is the unit? Newton per coulomb. This is the resultant electric field at midpoint, but we need to find out force. So force on which one? Force on a negative charge. Look at this, negative test charge placed at the midpoint of magnitude 2 nanocoulomb. So when we put a negative test charge here, that is minus 2 nanocoulomb, the force experienced by this test charge will be towards this side due to this one, because this one is positive, this one is negative. The force, nature of force will be attractive. Since this one is negative, this one is negative, the nature of force will be repulsive between these two. So this is FA, this is FB, there also it adds. And there is one more method to solve this. Okay, so that is direct formula. Look at this. First I will tell this. E is equal to F divided by Q. This we already know. Then if you want to find out F, if you just multiply by Q to E, you will get the force experienced by the charge. We already know what is E. So how much is that? E is 9 into 10 to the power 6. So multiply that by Q. Q is how much? 2 nanocoulomb. So let's calculate that. So Q value is, F is equal to Q value is 2 nanocoulomb into E value is how much? 9 into 10 to the power 6. Okay, so that is Newton per coulomb. Coulomb will cancel out, you'll be having Newton here. So 2 into nano is nothing but 10 to the power minus 9 into 9 into 10 to the power 6. So 9 2s are 18 into 10 to the power minus 3 Newton is the force experienced by that charge. Okay, this finishes this video. Thank you for watching this video. We'll meet you in the next video. Till then, take care. Bye bye.